So hello guys, it's Kumar K. Today I am feeling very tired, but I got many requests from lovely students like you to solve this super hard Amazon OA problem, which was recently asked few days back or few weeks back, and it's totally based on a very hard variation of string and multi-dimensional dynamic programming. Obviously, if you have only done standard DSA problems, you will not be able to solve it. It requires higher order thinking skills, analytical skills, and critical thinking skills. So let's directly jump to the problem. And yes, make sure you watch the full video so you can learn as much as possible from it. Ram Ram. So hello guys, with the name of God, Ram Ram. I know many of you are giving your Amazon online assessment in 2025 in August, September, and now in October as well. So I made the best Amazon OA roadmap video. Make sure you watch it. If you are my course student watching this video, then there are 100 to 200 Amazon OA questions, codes, and video solutions uploaded in the 851-hour course. Do them nicely. There are 95% chances of the same question appearing in your OA. And if you're a YouTube community student, go through the Amazon OA roadmap video. This document is in the description of the video. Please keep it with you all the times so it can help you. Now, this problem which we are going to discuss, obviously, it's a very difficult problem. Okay. So, the thing is that before I start discussing the problem, you guys need to understand that online assessments are a totally different breed. You cannot just do standard DSA questions of lead code, GFG, and influencer DSA sheets like Love Bubber, Striver, 200, 500, even 700 questions. Then also, you might have observed that in your college OAs and off campus OAs, you are failing them, right? Because for OA, you need different set of skills, and those skills are point number zero. You should know how to tackle hard unseen DSA problems. Okay. Point number zero, they give you large English paragraphs. So you need to have a very calm mind and succinct mind, which can, decipher the meaning of all the large like paragraphs given to you. So English comprehension skills needs to be good. And apart from that, you need to have this ability to solve any hard unseen DSA problem on the spot. So for this, you need lots of OA plus CP training and practice. That's it. Practice and training of many hard unseen DSA problems. That's it. Obviously, you can join my one-to-one mentoring plus job referrals plus 851-hour course plus daily life DSA plus OA plus CP training as well. It's available for all type of coders currently, beginners versus intermediate versus advanced. Now we can see that like this is the link to the problem, right? This is a super hard problem on string and dynamic programming. So if I open up this problem, you can see how big it looks, right? So I will try to make it easy for you. So first of all, you should know the lexicographic nature of the string. Okay, so Ram Ram. So if I give you two strings, how will you know which one is lexicographically larger? So I give you string one, I give you string two, right? Let's say string one is BADU. String two is CAAA. So which is string is bigger? I will not use the name lexicographically again and again. You should just understand that this is a standard definition. So if is S1 greater than S2 or S1 is less than S2. So the rule to check this thing is that you need to check the first character. Okay, always check the first character from the left. So if you check the first character from the left, for S1 it is B and for S2 it is C. So as soon as you find a mismatch of characters, see is B bigger or C bigger? C is bigger. Because C is bigger, the whole string S2 is declared as bigger than S1. Basically, if you put these words in dictionary, S2 will come after S1. That's it. That's the meaning of the best way to explain lexicographic order of strings is the dictionary order of strings. Let me give you some complicated strings like this. BADU, BADY. Now, what algorithm will you do on this? Well, from the left, you'll go to the first point, right? You can see that yeah, here also B is coming, here also B is coming. So nothing to check here. They are equal. So now check the second character. At the second position also in both the strings A is coming. So nothing to check. Check the third character. In the third place also, both the places D is coming. So nothing to check. Check the fourth character. In S1 U is coming, in S2 Y is coming. Is Y bigger or U bigger? Y is bigger than U, right, in alphabetical order. So S2 is greater than S1 in this case. Now, like the final thing you should know, that if I give you something like this, which is bigger? You check the first character of both the strings, they are same. But when you check the second character is not available in S1, but second character is available in S2. So whenever the character is not available at that particular index for a string, automatically the other string becomes larger than the first string. Okay. If I give you S1 as YZ, S2 as AB, in this case S1 will be greater than S2. Let's say I give you S1 as ABCU, okay, and I give you S2 as ABCC. So you check from left, it's matching, it's matching, it's matching, it's magic. So U here, C here, U is bigger than C. So as soon as you find an index where the characters are not matching, just check which guy is bigger. If this guy is bigger, just declare S1 greater than S2. No need to check the words after alphabets after that particular index. Okay. So hopefully you understand which string are lexicographically bigger. Obviously, if you're watching this video, you need to complete the dynamic programming course from this best warm-up course of 851 hour of DSA plus OA plus CP. The website link is given to you guys here. Please learn and extract as much as possible from here. Okay, Ram Ram. Now, guys, the question is that given a string A and B, you have to find how many subsequences in string A are lexicographically strictly larger than string B. Okay. So basically, two strings are given to you. String A, which is let's say bad, and string B, which is A. So how many subsets of A are lexicographically bigger than our whole string B? For ease of solving, I am assuming that string B has only one character. If string B has multiple characters, it will become very hard, which we will discuss in the part 2. So if you want part 2 of this video, please comment, okay, in the comment box for you. Now, so if I give you BAD, what are all the subsequences? BAD, what is the length? The length is 3, right? So for a 3 length substring, there are 2 raised to 3 minus 1 subsequences, right? This basic mathematical stuff you should know. For n length array or n length string, there are 2 raised to n minus 1 subsequences, non-empty subsequences. So 2 raised to 3, 8 minus 1, so it's 7, right? Okay, it's 7. Now, I want you people to listen to me very carefully. Which are those 7 subsequences? Well, it is B, it is A, it is D, it is BA, it is BD, it is AD, and it is BAD. 1, 2, 3, 4, 5, 6, and 7. Now, how to know which subsequences are? This is string A. The string B is a single character A. So, guys, out of all these subsequences, can you tell me A is larger than which subsequences? So, basically, which subsequence, not what A is larger than which subsequences. The question is opposite. A is smaller than which subsequences. Basically, out of all these subsequences, which subsequences are strictly bigger than A? You have to find how many subsequences are strictly bigger than our current string B, which is A. So B is bigger than A, right? Yes, so count it. Is A bigger than A? No, they both are same. D is bigger than A? Yes. BA is bigger than A lexicographically? Yes. BD is bigger than A? Yes. AD is also bigger than A. Why? Because see, first character you check A same. Next character here does not exist and here there is a D. So whenever at a particular index, if some character is not existing in some string, then the other substring becomes big. So AD is also valid. BAD obviously where it is A, it is B, na first character B valid. So how many are valid? 1, 2, 3, 4, 5, 6. 6 is the output. There are 6 valid subsequences of string A which are strictly greater than B. This problem is so difficult. Now, if I was teaching this in my live class, I would be deeply explaining the chain of thoughts which leads us to the solution. But because this is a YouTube video, I quickly need to jump to the solution because you guys don't have the retention power to watch the video for very long. So I will be directly jumping to the solution, but still I will give you a small hint. The first thing which should come in your mind is how to solve this problem if the string b has only one character, because even for one character the solution is very very difficult. Okay, obviously it involves the backward dp trick for subsequences, which I've taught in my course and training. You will not find it in standard DSA sheets and the standard DSA questions. So this is a very nice OA and CP trick, by the way. So before I discuss the backward DP trick with you, I want to discuss with you that how can you, think a little bit, how to arrive at the solution. So let's say this is BADY. Okay, this is string B. Okay, this is not string B, this is like, let's say string A. This is string B. So how will you know how many subsequences of A are greater than B efficiently? One way is you can solve the question in O of 2 raised to n, right? Generate by recursion and memoization, generate all the subsequences of this and check which of them are strictly greater than A. But there is another very nice way. One way is what one line of thought which should come in your mind is that my current character is A. So any character which is larger than A will be valid subsequence, right? So which characters are larger than A here? This B is a valid choice, this D is a valid choice, and this Y is a valid choice. Okay, fine. So B, D, Y are valid choices. You can easily count them. But guys, we are able to count all the valid length 1 subsequences. We are able to calculate all the valid length 1 subsequences. But how do we calculate the... See, length 1 valid subsequences, this thing is clear in your mind. Okay, I'm assuming you are an intermediate level coder who is watching this video. If you are not, complete my prerequisite course and then come back to the video. So guys, finding the length 1 subsequences which are greater than A is a piece of cake, right? B is greater than A, D is greater than A, Y is greater than A, 3 subsequences greater than A. How will you find the length 2 and length 3, and how will you find the subsequences of length 2, length 3 which are strictly greater than A? What is going to be the requirement? See, I can explain it to you in this nice way is that this is BADY, right? And this is A, right? What if you are trying to solve the question only for this much part? Let's say your string was only Y and you want to find in the Y what subsequence is there which is greater than A. What would be the answer? Answer would be a single character Y is greater than A. So answer for this much part would be what? 1. If the string was Y and A, only Y is bigger than A. So Y is the only subsequence bigger than A. Answer is 1. So we store the answer for Y and A as 1. Good, 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 good. Now, what if the question was asking you solve for A and dy? Then what would be the answer? The first string is dy and the subsequences of dy we have to find which are greater than A. So you know if it is Y and A, the answer is what? 1. Okay. So what you can do is you can calculate the answer in two parts. Dy subsequence is only made of two parts actually. Dy subsequence is only made of two parts. One part is what? One part is the part after D. Part after D is what? Y. And one part is the part which includes D. D and dy. Can you see the dy subsequence is made up of only two parts? In dy, if you try to make all the subsequences, length is 2, right? So it will be 2 raised to 2 minus 1. 3 subsequences, right? So for dy, the one subsequence will be what? Ignore d. Then whatever is the amount of subsequences of the string apart from d is what? Y. So you write y. And other subsequences are nothing but what? Subsequences whose first character is d. Means d should be there. So one is d only and another is dy. Okay. So guys, for this for the second part you already know the answer, right? You know that for dy, d comma dy comma y are the subsequences. and y is nothing but the answer for this part when this y was taken and this a was taken. So this y is already bigger than a. So the answer for dy and a will be what? It will be 1 plus something. This 1 is coming from where? This 1 is nothing but the answer of y when a. Why? Because all the subsequences of dy are constructed by what? They are constructed by only two type of subsequences. One is the subsequence which ignores d, and other are all the subsequences which forcefully include d. When we ignore d, it becomes the old string, and we know the answer for the old string. That's why 1 is written. But when we forcefully include d, how to calculate the answer in that case? It's pretty simple. It's pretty simple. Why? See, you now need very deep observational skills. This is the game changer. Okay. See, when you are looking at dy now, this d is bigger than a. Because this d is bigger than a, all the subsequences after d can merge with d, and still the subsequences will be greater than a. Why? Because the first character is bigger than a itself, right? What I'm trying to say is that if this was d, and if this was y1, y2, y3, y4, y5, and this was a, okay, and I'm trying to ask you how many subsequences of this string are larger than a. There are two type of substrings, you know, right? One are all the substrings which include d, like d, then d comma y1, like then d comma y2, then there are many possibilities in that, okay. And another is what? The ones which do not include d. So I am saying we know the answer for this already, because when you are calculating the answer for d, y1, y2, y3, y4, 5 and this a, it means you have already calculated for y1, y2, y3, y4, 5 and a. So that thing you don't need to worry. I'm asking about this part when the d is forcefully included. So d is bigger than a, so d is a valid subsequence, right? How many subsets can be created by y1, y2, y3, y4, y5? 2 raised to 5 subsets can be created. How many? 2 raised to 5 subsets can be created, and in all of those subsets if you add d in the start, it will become greater than a. Take any subset from this y1, y2, y3, y4, y5. You say y1, y3, y5. Let's say you pick this subset. This is one of the subsets from the 2 raised to 5 subsets. Y1, y3, y5. Now you picked any one of the subset. Now you take this d and you put it at the start. Now it looks like d, y1, y3, y5. D, y1, y3, y5 is bigger than a because the first character is bigger than itself a. Okay, so the trick is that you can see how hard this problem is to decipher if someone does not have a deep knowledge. That's why I say, tell you guys, please guys get clarity and help in your life. You cannot do everything in your own in this life. You need some help. Okay, so always do OA plus CB training as much as you can do. Now listen to me very carefully. You can book a one-to-one interaction call with me as well. When I get free, I'll talk to you. Now, DYA. Now listen to me. You know that for this part the answer is 1. And for this part, you just need to know what is the remaining length. The remaining length is 1. Apart from D, the remaining length is what? 1. So 2 raised to 1 is the number of subsequences which can be generated after dy. One will be dy and another will be d empty. So 2 raised to 1, 2. So two subsequences from here, d and dy both are greater than a. So 1 from here, 2 from here, 1 plus 2, 3. 3 subsequences are there like y, d, dy which are all greater than a. So life is pretty chill and easy. You can apply this formula again and again until your job gets done. Let's say u, dy, okay, and a. This is your string a and this is your string b. First you calculate answer for this part, this y and this a. For this y, this a, you know that the answer is going to be 1. Now you calculate the answer for if the string was dy and a was given to you. Dy is again constructed of two parts.
One part is y, another part is all the subsequences which contain d. For this part, the answer can be borrowed from this one. I borrow here because for this, for dy, one of the subsequence is y. So basically, y and a you have to solve, and y and a you have solved in the past, which is 1. For d and dy, nothing to be done. You know that d is bigger than a, right? So all the characters after d, you can generate all their subsequences and join them with d, and it will still be bigger than a. So how many characters are there after d? One character is there after d. So 2 raised to 1 empty and non-empty subsequences can be created. So 2 raised to 1 you will add. So d comma dy, 2 raised to 1 added. 2 raised to 1 plus 1, 3. So guys, for dy comma a, the answer is 3. Now, we will now calculate u dy with a. Again, u dy, there are only two types of subsequences possible for u dy. One are the subsequences which forcefully include u, like u, ud, and things like that. Another is what? Another is nothing but the all the subsequences which are getting created when u is not there. Basically, if you only consider the string dy and a, then what would be the answer? This is the second part of subsequences. So for dy and a, the answer is 3. So second part of subsequences, the answer is 3. First part of the subsequences, u is strictly greater than a, bro. U is strictly greater than a. So just check how many characters are there after u. There are two characters. So 2 raised to 2 subsequences can be made. Out of dy, 2 raised to 2 subsequences can be made, which are dy, and empty. Now all these 4 subsequences can be joined with u. Ud, uy, udy, and u and empty. Nothing, only u. And these 4 will be the correct subsequences strictly greater than a. So 4 from the upper part and 3 from the lower part. 4 plus 3, 7. So guys, we can just use a dynamic programming, right? We can just use a dynamic programming, right? Backward dynamic programming, baby. So what I mean to say is, that listen to me very carefully, okay? Let's say this is index I, okay? And this is your character. This is string A, this is string B. In string B, there is only one character. Can you see? Even the solution for one character is so difficult. In part 2, I will be explaining how to solve the problem if B also has multiple characters. Let's say for string B, the only character is U, okay? So what will be dp of I? dp of I means if you consider only this much part of the string, how many subsequences of this much part of the string are strictly greater than this particular single character? So dp of I will be what? Basically, the string from index I till n minus 1 is created using two parts, right? One is all the subsequences forcefully including I, and another is the subsequences which do not contain I, which are starting from I plus 1. So for the lower part, answer is easy, right? What will be the answer for all the subsequences which are created from the I plus 1 part? From I plus 1 till n minus 1. It will be nothing but dpi plus 1, which I have already calculated because you are doing your calculation in backward direction like this, okay? So for this part, the answer will be dpi plus 1. And here, let's say this is u. Now let's say at index I, the character is a b c d e f g h i j k l m n o p q r s t u v, or let's say v, okay? So you can see that v is strictly greater than u, right? Yes, sir. So v is strictly greater than u. Okay, fine. So because v is strictly greater than u, v is strictly greater than u. It means all the characters after v, you can take all the subsequences, empty plus one non-empty subsequence of this, and join it with v, and still it will be greater than u, right? So let's call this length as L. The number of characters after V, let's call it as L. So 2 raised to L. So dp of I, the formula is dp of I is equal to dp of I plus 1 plus 2 raised to L. That's it. This is the correct formula in the case when A of I is strictly greater than B of 0. When this character is strictly greater than this character. Okay. If this character was less than this character, then what would you do? That's also easy. Let's say instead of V, it was A. It was A. Then what would you do? There are only two type of subsequences possible, right? One is from I plus 1 till, and another is from where you are forcefully including A. All the subsequences where you are forcefully including A, they can never be bigger than you. So you just need to remove this second part. In the other case where A of I is strictly less than B of 0, in that case the formula will be dpi equal to dpi plus 1. That's it. You can analyze it later by watching the video deeply. Another is last case is, what if it is u only? Instead of u v, it is u only, same. Now you need to be a little careful, okay? Obviously the subsequences are getting created by two parts. One part is this I plus 1 part is always there, dpi plus 1. Another is all the subsequences where u is forcefully included. Because u is forcefully included, any subsequence you add here and u, it will always be greater than a single u, right? But you can add only non-empty subsequences. Be very careful about that. So how many letters are there here? Let's say there are L letters here. So instead of 2 raised to L, you will add 2 raised to L minus 1. Why? Because one subsequence will be empty subsequence. And if you take empty subsequence from here, then U plus empty will be U. And this U will not be greater than this U. So U, if the first character is fixed to be U, then it can join all the other letters from I plus 1 to N minus 1 in any subsequence format as long as they are non-empty. Okay. Empty subsequence, if you add with u, it will just say u, and u is not bigger than u, right? Obviously ua is bigger than u, ub is bigger than u, but u is not bigger than u. So 2 raised to L minus 1 you gotta add. That's it, guys. I hope you got the logic. I know it's very complicated. So we will be dp of I will just be meaning, how many subsets in the range I to n minus 1 are strictly greater than b of 0. Like as we taught in, like I have discussed it in previous multiple dynamic programming videos. Like if you really want to master dynamic programming, I would really suggest you that you go to this prerequisite course and please watch the 5 dynamic programming videos given here. They will really help you a lot. Trust me, please watch them. I have taught dynamic programming in a very different way, which makes you ready for OA plus EP level also. And in 2025, you really need to become very strong. Okay. So whenever you can go through the C++ and Java Python codes also. For the easy version, if you want part 2, you can let me know in the comment, where B can have more than one character, and you can write your own logic also. This was the most important thing. If you have figured this out after some thinking, you can figure out the solution when B has multiple characters as well. Obviously, it is n into m time complexity, where n is the size of a string A and m is the size of string B. So you can see if ai greater than b0, then this is happening. If this is less than this, then this is happening. When this is equal, 2 raised to L minus 1. Be careful, okay? Like if I write here BAD, okay, and like BADY, and if I write here A, so if I run this code, like Java code is also there, Python will also be uploaded. For loop if else is easy for you people, right? So hopefully you guys got it. Whenever we do DP now, we always declare a very big DP array, one dimensional array initially, and we try to define the meaning of dp of I. Generally, dp of I is the best answer from index 0 to I. In this weird case, because we are doing subsequence calculation, we need to go from back. dp of I is the best answer of this much part in this case. Okay. So hopefully you guys liked it. See, for each index it has calculated. First it DP0, 1, 2, 3, DP3, DP2, DP1 and DP0 is the answer. In our case, in general cases DPN is the answer, but in our case DP0 will be the answer because we first calculated the suffix part and now we are coming here. Okay. So hopefully you guys enjoyed this video. Ram Ram. God is always with you. Ram Ram.